Welcome back to Nick Does Maths with me, Nick. Some maths here, there on the screen up there. There's some maths, and we are going to go through it. Again, we're going through some sort of maths Olympiad style problems, a little bit longer, so we are going for floating head. Woo-hoo. How are we feeling about it? Let's find out. Find all positive integers n such that x, that should be an n. Great way to start. N times 2 to the n plus 1 is a square. Now, with any of these, it is worth starting just putting a few numbers in. N is 0. Okay, we get 1, which is 1 squared. So that's cool. N is 1. We get 2 plus 1, which is 3, which is not a square, so that's no good. N is 2. I get 2 times, what was it? 2 times 4, which is 8, plus 1 is 9. Ooh, that's 3 squared, so that's nice. N is 3. 3 times 8 is 24, plus 1 is 25, so that's 5 squared. N is 4. I mean, we're not like these numbers are going to get real big real fast, right? So 4 times 16 is 64, plus 1 is 65. That's not a square number. All right, I'll do N is 5, and then we're going to give up. 5 times 2 to the 5. 2 to the 5 is 32. 5 times 32 is 160. So this is 161, which is not a square number. So let's stop there, because obviously this is going to get out of hand real quick. And we don't want to have to just keep searching. So let's see if we can do something with this. All right, basically what I'd quite like is to know when can I stop looking, right? I've gone up to n is 5. When can I stop? Well, let's see what would need to happen for this to be a square. So I'm going to say equals k squared. Now, the thing that we like here is I can write that as k squared minus 1. So n, 2 to the n is k plus 1, k minus 1. All right? Now, here's the thing. This is obviously even, right? Because it's a whole bunch of powers of 2 times something. Fine. Now, we've got two numbers that differ by 2, which means either they're both even or they're both odd. So they are both even. All right, they are both even. They both have to be even. They both have to be even. All right, because otherwise they're both odd, because they are differ by 2. K plus 1, k minus 1. So if you're going up in twos, if one is even, the other one's even. If one is odd, the other is odd. But because their product needs to be even, they both need to be even. So shall we say k plus 1 is equal to 2m. K plus 1 is equal to 2m. Doesn't really matter. I might go k minus 1 is equal to 2m, in fact. I might go k minus 1 is equal to 2m. So this tells me that n 2 to the n is equal to, so k minus 1, k plus 1 becomes 2m plus 2, and this becomes times 2m. So what I can say is now 2 times 2 to the n minus 2 is equal to m plus 1 times m. Now this is interesting, because these are consecutive. So one is even, one is odd. One has to be even, the other one has to be odd, or the other way around. Okay? Right. Now the even one, what we're going to notice, of course, is not only is it even, but the odd one has nothing to do with this. The odd one can have nothing to do with that 2 to the n minus 2. All right? So we're going to look at the two cases here. So let's say m plus 1 is even. M is even. Let's go m is even. So m is equal to, not only is it even, but it's some multiple of 2 to the n minus 2, because all of those factors of 2 have to be in there. So it's going to be some multiple of that. I've used k, so let's go for a. So it's a lots of 2 to the n minus 2. Okay, so we can go m is even. So we are going for the case m is even. Okay? So we get one even, one odd, or vice versa. It doesn't really matter. We're going to check both cases. But the even one, here's the real key, the even one needs to have that 2 to the n minus 2 in it. So it's something times 2 to the n minus 2. That something could be anything because, of course, there could be multiples of 2 in n. N could be even in some way, but that's not the point. Okay. Right. But what do we know? Well, here's the thing. M plus 1 is bigger than or equal to m. In fact, so what does that tell me? So we know that n to the 2n minus 2 is bigger than or equal to, or is equal to, in fact, is equal to m plus 1 times m, a2 to the n minus 2. All right. So this tells me that n is a times m plus 1. Well, that is bigger than or equal to m plus 1. A is a whole number, right? Everything here is an integer. But m plus 1 is bigger than or equal to m, and m is bigger than or equal to 2 to the n minus 2, right? If m is equal to a to the 2n minus 2, then m is bigger than or equal to 2 to the n minus 2. All right, so where does that take me? Well, it tells me that I need values of n such that n is greater than or equal to 2 to the n minus 2. All right. Now, this is an exponential graph. This is an integer. This is just the identity. So if we compare the two, n and 2 to the n minus 2, n is 1, that's a half, n is 2, that's 1, n is 3, that's 2, n is 4, that's 4, n is 5, that's now 8. And this one is going to grow faster. So actually, this is only true for n less than or equal to 4. Okay, so if n is even and less than or equal to 4, for this to be true, so for this to be possible, right? So don't forget, we've gone all the way back to this being a square. So for this to be a square and n is even, n has to be less than or equal to 4. Okay. Well, in the case m is even. Sorry, in the case m is even. Now, the other case we had to check was, what if m plus 1 is even? All right, so we're checking our two cases here. M is even, m plus 1 is even. So now m plus 1 has got all of the n minus the 2's in it. All right. Okay. So now n 2 to the n minus 2 is m times a 2 to the n minus 2. Okay. Now m is, now we want to do a similar thing to up here, but we don't have what we want. So I'm going to try and write this in terms of m plus 1. So that is m plus 1 minus 1. Ooh, don't forget the a. Okay, so we can do the same trick as before. That is, n is greater than or equal to m plus 1 minus 1, which is greater than or equal to a2 to the n minus 2 minus 1. And of course, the a just makes this whole thing bigger. So we end up with n is bigger than or equal to 2 to the n minus 2 minus 1. So there we have it. And let's see what that does for me. So 2 to the n minus 2 minus 1, well, that's minus a half, that's 0, that's 1, that's 3, that's 7. And again, 2 to the n minus 2 is just growing exponentially. So again, the cutoff point, the last bit where that works, is n is less than or equal to 4. So in either case, whether m is even or m plus 1 is even, we only need to consider the values of n that are less than or equal to 4 for this to even be a remote possibility. So in which case, our cases that we looked at here are correct. Now, 0 is not what we want in the positive integers. So the only cases that work for me are n is 2 and n is 3 are my only two possibilities. Woo! Little bit weird, that one, right? You have to get your head around what we're looking for. We're trying to find bounds on where I need to look. So this is still a little bit searchy, right? We're just trying to manually find the values of n, but we want to put a boundary on that, which is why the inequalities start coming in. Once we get our head around that, it sort of clicks into place, but a little bit funky. How are we feeling about these sort of Maths Olympiad ones? We're going to go back to some more like straightforward further maths questions as well over the next coming weeks. I just saw these and thought they were really cool, so thought I'd talk to you about them. Drop us a comment. Did I get anything wrong? Does my logic not follow? Let me know. Otherwise, I'm Nick. Don't forget to like, subscribe, hit the bell for notifications as we go through. Don't forget to check out our further maths courses and maths courses running out throughout the year here at my Headspace to see if you want to come hang out and talk maths a couple of times a week. All the details are in the description. I'll see you next time.